In all these cases, no work is done by the friction force.
Sir, sir,
Huh.
sir, why is the sir, since the friction, since it is point of contact, it's
Yes.
not changing, the work done is zero, sir. We should consider as
What is not changing?
because the friction acts as a point of contact of the ground and the body, no, sir.
Yes.
Since the point of contact is not changing, the friction is zero, sir. Here,
Yeah, point of contact is at rest. No, friction is not zero. Work done by friction is zero.
yes, but
Friction is there. Without friction, you cannot accelerate. Friction is the reason of your accelerating. F equal to ma, that F is friction. Because of the friction only you are accelerating. You cannot accelerate by internal force. But that external force is not doing any work. Work is done by the internal force. Are you getting it?
I'm getting. Sir.
Try this question. Tell me, who is right, Harshit or Akanksha?
Sir, reading, sir. Questions.
Hmm.
Cause of the cause of Akansh is right. Akansh.
Yes. Akanksha is right. This statement is correct that without friction, the man cannot run. And that is also not correct. But yeah, from rest he cannot run, but he can keep running without friction also, right? Running means not in the actual sense, like means if something is at rest, then he cannot accelerate actually. Without friction, he cannot accelerate, but he can keep moving no, without acceleration if someone imparts some initial velocity. But this statement is totally wrong that cause of increase in kinetic energy is the work done by the friction force. This is wrong. Without friction, man cannot run. This is also correct because run means what? Something is starting from rest and then moving. So,
So without friction, can also the man can run. Also, I can say.
but that will not be called as run. He will slip, right? Slipping.
Okay, sir. Yes, sir.
That will not be running. Yeah. He will keep sliding, but will not call that run. But anyway, this is totally wrong. That increase in kinetic energy is the work done by them. This is correct. So you understood the importance here that the force which is responsible for acceleration, maybe that force is not doing any work. Are you getting?
Yes, sir. I'm getting, sir.
So now here you will understand a very important thing that Newton's second law says net work done sorry, net external force is equal to m into a. Net external force, right? Can we say sum of all internal force will be always zero?
Sir, sir, we cannot say no. So some of all
We can
always
say
zero.
always zero. It will be always zero.
Sir, when we take
I'm not saying work done by internal. I'm saying sum of internal force will be always zero. Yeah, tell me any situation where it is not zero.
there is a body is hanging, sir. If you assume.
Okay. Hmm.
Then tension is an internal force, no, sir.
Tension is the internal force, that is wrong. Tension is internal force to what? What is your system?
So that block plus that rod, that string, both are systematic.
That is also not correct. Suppose block plus, uh, if block plus string, uh, block plus string is not the system. Are you getting? Block plus string plus ceiling also you have to consider. If there is no ceiling, how the block will hang with the block is
It's a block plus string for the ceiling of the system.
so
And
then
friction will
then the
tension.
then the tension is zero because the tension is acting on the block and acting on the ceiling also. Are you getting what I said? Sum of all the internal, right?
Yes.
It will be always zero, always. If it is not zero, then it will be equal to ma, no?
Yes, it will be cost enemies.
But it will be always zero. Why it will be always zero? Because of Newton's third law.
For every action there is no.
Understood?
So, but the action and reaction can act or cannot act on. They act on different bodies, most of the time.
That's why we are not talking about the internal force. We are talking about sum of all the internal force.
Okay, second.
So when you take sum of all the internal force, when you will count A, you will count B also, no?
Yes, sir.
And internal force on A in this direction, then its pair will also exist, no, in the same system.
Yes, sir.
It is in the same system. That's why we are calling it internal, no? If its pair lies here, then it is not internal. Are you getting?
Yes, sir. Okay.
Okay, so that's it for today. Now you start some problems from work energy power in that HCV also. And in SCV, always you start from the solved questions in the at the end of the exercise, and then go to MCQ1, MCQ2, and then you go to the exercise. But only solve those questions which are from this part, work part. Now, work part, you can solve all the questions. Okay. Work and work energy theorem, energy, and this part. But up to kinetic energy, work energy theorem. Now, other important topics are left, which we will discuss in the next class. Okay. You have any doubt, you can ask.
Sir, means,
Yeah.
sir, we are saying that so since the point of contact of the friction is not from the fractal friction is zero, no, sir.
Yeah.
Sir,
Point of contact is not moving. Yes.
sir, but when we are moving, the point out contact is also changing, no, sir.
Means which situation you are talking? Running situation or what situation?
Sir,
Give
in
me any
case of
situation.
so in case of running only if it takes, then there if
In
we are
case
moving
of
forward.
running, the point of contact, you are saying it's changing, right?
Yes, sir.
Yeah, but when the point of contact is changing, at that time force is not acting, no? Because the person is here and the person is running. So when he is running, his one foot is in air. Are you getting?
Yes, sir.
And one foot is at rest. Are you getting?
Yes, sir.
Friction is acting here, no? But it is not moving. Now, when he will keep this foot, he will lift this foot. And then friction will disappear. Then this foot will start moving. Are you getting? Force and displacement both should be there at the same time. Now, when force is there, displacement is not there. When displacement is there, force is not there. Are you getting?
I'm getting sir.
That's why no work done. Yes, point of contact is shifting, but when it is shifting, at during that time of shifting, no friction is acting on that leg. Are you getting? Because that leg is not in contact with the ground, which is shifting. Are you getting? And the leg which is in contact with the ground, that leg is at rest, not moving during that interval of time. And when that leg starts moving, then there is no friction on that leg. Friction also shifts to the other leg, but the other leg is now at rest. So no work, always no work in this case. Work will come only when his leg will slip with respect to the ground. Then kinetic friction will come and it will do work.
I mean, at a time, both work and displacement only. So means force and displacement, force due that displacement exists only, work exists no, so we can
If they will not exist, then uh, how you will take the dot product?
I mean, both should exist. I'm asking.
Yeah, so that why you are asking that means if if something does not exist means what is its value?
Zeros, zeros.
Yeah. So if something exists and force exists, displacement do not exist. So then you take its dot product with zero, you will get zero, zero vector. And when displacement will come, force is zero. So then again take dot product, again you are getting zero. So formula will always help you. You can apply formula all the time. But yes, here you have to understand one very important thing that when we calculate work, work is dot product of force and displacement. But now here you have to understand very important thing that this displacement is the not the displacement of the body. This displacement is the displacement of point of application of force, the point where force is acting. For example, if this is a rod and rod is kept on a horizontal surface, rough surface, okay, and suppose you are pulling the rod, you started pulling it by some constant force for some time and then you left it. So now because you pulled it for some time, the rod will shift on the horizontal floor and will come to some this position like this. Are you getting? Right? This will happen now
Yes, sir, it will happen.
because the friction is also there. So, and now here you can see that the center of mass of the rod is was here initially and now it reached here, and its displacement is, let's say, d. Displacement of the center of mass of the rod is d, and the force that is applied is always constant and it is F. Can we say that the work done is FD?
No, sir. Means we should no, sir. We should consider the displacement of the point. No, sir.
That's it. Okay, so that's it for today. So you have to consider the point of application of force and not the center of mass, not any other point. Different point have different displacement here. You can see, right? But you will only consider the point of application of force. Maybe the whole body is moving, but the point of application of force is not moving. That situation is also possible. And maybe point of application of force moving, but the body as a whole not moving. For example, a spring is there. When you stretch it, the complete spring do not move, right? One end of the spring is fixed. Different part of the spring have different displacement. The part which is connected to the wall have zero displacement, right?
Yes, sir. It will have zero.
But work has nothing to do with the displacement of any other part. Work has to do with the displacement of that point of the spring where the force is acting, point of application of force only.